Section 8 is on simplifying trig expressions. If you did not understand the unit circle, 7.5, if you did not understand how to find ratios and evaluating trig functions of 7.3 with degrees and 7.6 and 7.7 with radians, then 7.8 is going to be really hard for you. You have to understand what we've done before in order for you to understand what we're going to do here. I've only added some very few directions, and I only have 2 examples for you to do. But if you don't understand the previous stuff, then this stuff is going to be very difficult for you to do. So let's make sure that we're clear. If you need remediation, I'm starting to get lost, Mr. Promo, then make sure you're going back and watching some of the previous videos. And it might be wherever it is that you are stuck. It could be on the degrees, it could be on radians only, I'm not sure. But here we go. Trig functions have angles that are inside parentheses. Please excuse my dear Aunt Sally, in order of operations, or therefore, I'm sorry, that's what the 3 dots means. The 3 dots means therefore. Therefore, in order of operations, trig functions should be done first as you do these things. So when you're doing problems that look like number 1, some of you are going to see this squared and think that you need to do the squared part first. But what I'm telling you, since you've never done this before, is that you're supposed to do parentheses before you do exponents. You're supposed to do groups before you do exponents. And I don't know if you learned it as PEMDAS or if you learned it as GEM, so let me do a quick survey. How many of you, when you were in elementary school, your elementary school teacher taught you PEMDAS? Raise your hand. Thank you. That looked like almost the whole class. How many of you, your elementary school teacher taught you GEMS? Raise your hand. There's few of you. Okay. For those of you who've never seen GEMS before, G stands for groups. P is parentheses. G is groups. The reason why people like groups, there's certain math teachers who like that, is because then you're going to think of a group or as not just parentheses, but you might think of it as a group that's above, a division sign or something like that. This is considered a group, this 1 plus 2. You have to do the group first. Why is it a group? Because of that line. You're saying 1 plus 2 divided by 2, the whole group divided by 2. So keep that in mind. That's why some people like GEMS instead of PEMDAS, just so you know. We are going to do the trig functions first when we do these problems. Exponents are written next to the trig functions so that you don't think it affects the angle. So let me show you what I mean. We have 2 examples today. You do not have to do them in your notes. If you want to do them with me in your packet, you are welcome to do so. So number 1, I want to read this little thing that we wrote down in our notes and then talk about this problem real quick. It says, exponents are written next to the trig function so that you don't think it affects the angle. There is a very specific reason why that 2 is next to the sine part of your equation. This says the sine squared of pi over 6. They write it that way so that you don't think you have to square pi over 6. They do not want you to think that that means that you're doing pi over 6 and times pi over 6 at all. What this actually means, if I were to write it out, it means that I'm taking the sine of pi over 6, and you have 2 of these groups. That you have a sine of pi over 6 times another sine of pi over 6. There's 2 of the trig functions, and each trig function has their own separate angle. If you wanted to, you could write it like this with the squared outside the parentheses, but I don't want to do that. I I just wanted to show you what it means. Now, if you know this, and you know your order of operations, you're going to do this sine of pi over 6 first. Now, I know what the sine of pi over 6 is. First thing is I know pi over 6 is in quadrant 1. And I know what my ordered pair is. It goes like this, where it's root 3 over 2, comma 1 over 2. And I know that the sine is the y value of that unit circle. Of that coordinate in the unit circle. So the sine of pi over 6, if you know what the sine of pi over 6 is, then you replace it. Sine of pi over 6 is 1/2. If you are a hand trick person, 0, pi over 6, pi over 4, pi over 3, pi over 2, I fold down pi over 6. The left side is the cosine. The right side is the sine. The square root of how many fingers over 2? The square root of 1 over 2 gives you that ratio. Cosine, square root of 3 over 2 gives you that ratio. So that is what I'm doing. And that's the first one. The second one is this. So what you have here in this problem is you have 1/2 times 1/2, which we're now going to multiply the numerator times the numerator and the denominator times the denominator. And my answer is pi over, not pi over 4, 1 over 4. I'm sorry. Now that you've done that, I want to show it to you how I actually do it. Okay? Because what I just did right there is how I'm showing you all my work. When I'm dealing with this problem, this is what I actually do. I go like this. The sine of pi over 6. I figure out what that is. And I know that's 1/2. And then I take this 2 and I put the 2 right there. And I do 1/2 times 1/2 and I get to 1/4. For me, that's a whole lot easier than breaking it apart, finding 2 different things and stuff like that. So this is how much work I actually do here in blue. You are welcome to do the red step or the blue step. They mean the same thing. There's just about that much work to do for number 1. I hope that makes sense to you. Let's jump to number 7. Number 7 says the square root of sine of 150 degrees plus the cosine of negative 60 degrees. All divided by 8 times the secant of 60 degrees. Woo! That's a big one. So we're just going to do this by piece, and hopefully you'll see how to get this answer. I'm going to do this piece first, the sine of 150 degrees. First thing I think of when I'm dealing with that is I think, okay, 150 degrees is in quadrant 2. Is the sine positive or negative in quadrant 2? I know it is positive. And then I think, what's the reference angle? 150 degrees is how close to the x-axis. And I'm hoping you'd think of a number, of an angle. I hope you think it's 30 degrees. And you fold down that finger and you find your sine, square root of fingers over 2, and you know that that red piece is the same thing as 1/2. Then what I'm going to do is I'm going to do this next group over here, this cosine of negative 60. I'm switching colors because I want you to know how piece by piece of the angles that I'm drawing. Cosine is 60 degrees. Negative 60 degrees means instead of going in the positive direction, I'm going in the negative direction, and I'm over here in quadrant 4. Is the cosine positive or negative in quadrant 4? Tell the person you're sitting next to. I'm hoping you said it's a positive value, because it is. Degrees, 0, 30, 45, 60 degrees. I fold down 60 degrees. I count square root of how many fingers divided by 2. I get 1/2 again. Then what I do is I go down to the denominator and I have this 8 that is multiplying the secant of 60 degrees. So when I'm thinking of the secant, I'll do this one here right in green. Here's 60 degrees. 60 degrees is the cousin. Secant is the cousin to which one? I hope you know. Cosine. Good. So that means if I know the cosine of 60 degrees, I have down that the cosine is 1 over 2 and the sine is root 3 over 2. The cosine's 1 over 2, but the secant is the reciprocal of 1 over 2. Which means, instead of 1 over 2, this is 2 over 1. And now we have done our trig function first. Remember, this is a group. I have to do what's in the group first. This line puts this numerator in the group, and I have to do the 1/2 plus 1/2 first. So I'm going to do that. I'm going to switch colors here to back to red. 1/2 plus 1/2 is 1. And I have 8 times 2, which is 16. It's technically over 1, but anything divided by 1 is itself, so I'm going to leave that at 16. And because I'm square rooting the 1 and the 16, that means I can square root 1 and I can square root 16. I can square root both of those, numerators and denominator, separately. And so the square root of 1 is 1. The square root of 16 is 4. My answer to this question, oddly, is the same answer as it was to number 1, which is 1 over 4. And that is how you're going to do the problems like that are on worksheet 8.